Right, guys. So today we will be discussing and looking at the trends that are seen in the periodic table. Right. So we call this the periodic table, and we study about 20 basic elements. We study about 20 basic elements from hydrogen to calcium. When we look at this periodic table, guys, we see some trends, mainly seen from left to right of the periodic table and from top to bottom of the group. Okay, so in the periodic table we call the rows as periods, and down the periodic table we call them groups. Right. Now if you look at this, there's a feature called electronegativity. There's a feature called electronegativity. Basically, in the periodic table, this is one of the main features that we can see, the electronegativity and the ionization energy. If you look at the electronegativity, students, from left to right, you can see that the electronegativity of the elements are increasing. What is electronegativity? Can someone tell me what electronegativity is? The electronegativity is, in a bond, the ability of an atom of an element to attract electrons towards itself. When two atoms or elements bond, the ability of that atom to attract the electrons present in the bond towards itself, we call it electronegativity. If you look at this, let's say hydrogen and chlorine, hydrochloric acid or hydrogen chloride. So in this bond we have electrons. Here I have given the electronegativity values, and if you look at them, we have, for hydrogen we have 2.1 and for chlorine we have 3. So highest electronegative element is what? Chlorine, right? So the ability of the chlorine has the highest ability to attract the electrons in the bond towards itself. Is that clear to you? Right. So like that, across the period from left to right, we can see that the electronegativity increases across the period from left to right. We can see the electronegativity is increasing, and down the groups, you can see that the electronegativity is what? Electronegativity is decreasing, right? Yeah? Yes. What about the ionization energy? What can you all say about the ionization energy? That's also one of the features, that one of the trends that can be seen in the periodic table, the ionization energy. So there's a graph when we come to first ionization energy. Now I will be drawing the graph. Have a look at it. Right. So this is the first ionization energy graph. Now what is first ionization energy? The first ionization energy is the energy that is needed to be provided to a gaseous atom to make it a unipositive gaseous atom. The energy, the minimum amount of energy that needs to be supplied to a gaseous atom to convert it into a unipositive gaseous ion. Is it clear to you all? Let's take an example like this. Let's say sodium gas. By making it Na plus, sodium plus electron, the minimum amount of energy that should be supplied to this in order to convert it into this. Understood? Na plus. This is the ionization or the minimum ionization energy required, converting sodium gas into sodium plus gas. Understood? Is that clear to you all? Right, now by looking at the graph, what can we all say about this ionization energy? Can you see when going down the group, in each and every group, when going down, what happens? The ionization energy will decrease. There is a decrease in ionization energy of hydrogen, lithium, sodium and potassium. But when going across the period, we can see the ionization energy is increasing. Is that clear to you? The ionization energy is increasing across the period. Here, ionization energy is increasing across the period. Hydrogen to helium and lithium to neon, the ionization energy is increasing. Right. So let's write on the board. Ionization energy decreases down the group, and ionization energy increases across the period. Well, what are the other things that we can say by looking at this? Now, here in the periodic table, there's one more thing. This is group 1. We are using Roman numbers to name the groups. So if you look at group 1 and 2, we call them metals. Here group 1 and 2, we have metals. Group 1, we have alkali metals. In group 1, we have alkali metals. We call them alkali metals. In group 2, we have alkali earth metals. So group 1, alkali metals. Group 2, alkali earth metals. So group 7 and rest of these are nonmetals. Here aluminium, silicon, we have metalloids. Which have both metals and non-metallic features. So in group 7, elements in group 7, we call them what? What do we call them? We call them halogens. Group 8, special guys. So these are the inert elements or noble gases. We say noble gases. Why? They don't participate in making of bonds. They do not usually react. Okay, so the noble gases are like the introverts. They are the introverts of your friend group. So this is the friend group, and here we have the introverts, the noble gases. Right. Okay. Now when we come to group 1 and group 2, we have the metals. They react with oxygen. The metals react with oxygen to form their relevant metallic oxide. They react with oxygen to form their relevant metallic oxide. Is that clear? Right. So the relevant metallic oxide further reacts. If we further react them with water, they will form their hydroxide. Let's get an example. Let's say sodium will react with oxygen oxide. The sodium oxide further reacting with water, we get sodium hydroxide. Yeah? Correct. So sodium hydroxide. This we call them a base. What is a base? The base has the ability to release OH minus ion or hydroxyl group. We call it a hydroxyl group. The sodium hydroxide. The hydroxides have the ability to release OH minus ions into the aqueous solution. We call them the compounds which release OH minus ions or which ionizes the aqueous solution with OH minus ions. We call them bases, and the compounds that release H plus ions into the solution, we call them acids. Right. So if you look at sodium hydroxide, it has the ability to give, sodium hydroxide has the ability to release OH minus ions into the aqueous solution. So this is a base, we call it a base. The basic nature, if you consider the basic nature, it decreases across the period, and the acidic nature increases across the period. So when going towards the right, let's consider HF. It has the ability to release H plus ions into the aqueous solution, that it can ionize the aqueous solution with H plus ions. So when it ionizes the solution with H plus ions, we call it an acid. So depending on the amount of H pluses and the OH minuses that they release into the aqueous solution, we call them what? Strong acids. We categorize them into strong acids, strong bases, weak acids, weak bases, so and so. And we have neutral compounds as well, right? Such as water. So if they release completely ionized, if they completely ionize the aqueous solution with OH minus ions, we say it's a strong base. If they partially ionize the aqueous solution with OH minus ions, we say it's a weak base. Right. So from sodium to magnesium, when it goes from left to right, sodium is a strong base, magnesium is a weak base. The basic nature decreases, the basicity of the compound decreases, and here the acidity increases. So the basic nature decreases and the acidic nature increases. So hydrogen fluoride, hydrogen chloride, sulfuric acid, which is H2SO4, they are strong acids because they can completely ionize the solution with H plus ions. Now if you consider H3PO4, which is formed with phosphorus, the aqueous solution of phosphorus, it's a weak acid because it cannot fully ionize the aqueous solution with H plus ions. It partially ionizes the solution with H plus ions. We call it a weak acid. Is it clear to you? Right. So the basic nature, let's say I write on the top, basic nature. Basic nature, what happens to the basic nature? It decreases. What happens to the acidic nature? Acidic nature, it increases. Right. So those are some of the trends that you all need to know. For your age, these are a few trends that you need to know about the periodic table. We can further talk about the bonds, which are ionic and covalent bonds. We will be discussing it in the next session.